Kia ora everyone. In this video, I'm going to show you how Pytest work. Pytest is a Python package that's used to write automated tests to test your code. This allows you to write really robust code as well as code that is professionally looking. I think the best way to show you how Pytest work is by example. So let's jump straight in. Great, so I've got a terminal open up here. I've just pre-written some things. So I've got a few directories set up and I've got this thing called pip file. Pip file is what comes from pipenv. Pipenv is a way to manage your dependencies as well as a virtual environment. I've already installed Pytest on here, and I can use the tag --dev. So that means this package is actually a development package, not what's used in production. And you can see I've already installed it. Well, I thought I had anyway. Great. And if I go into the pip file, you can see that nothing else is really installed. And in the dev packages, we've got Pytest. The function I'm going to be writing today is basically a maths function. It will create an object, or a maths class. It will create an object, and with this object, you can add numbers to it and subtract it. Really simple stuff. So what we're going to do is we're going to create our functions.py file. This will contain all our code, and we're going to create a directory for tests. The tests will be basically a module that contains all our test code that's used to test our function code. Touch tests. We create an init file just to show that Python that test is actually a module. Touch tests. Test underscore function.py. And we're going to have something looking like this. We've got our functions.py file in our kind of our root of our project, and we've got our tests function in the test directory. Great, let's write our code. So I'm just going to go vim function.py, and I'm just going to write a comment function.py, and all we're going to do is we're going to write a simple class. So class, and we'll call it maths, and we'll define its constructor. This will take some input. We always have to pass self, and we'll call the starting number in, and we're going to use typing. So although typing is not really done, Python doesn't do anything with typing, it's really good practice to show what type of sort of input you want to get. And in this case, we want n to be an integer. N. And what we'll also do is we'll define a representation. So representation is when we print that object, what will actually be printed onto the console. So that takes self, and what we do is we'll return f-string. And what an f-string is, it allows us to use curly braces to evaluate Python code. Let me show you what I mean. N is self.n. And what the f-string will do is Python will evaluate the self.n, which is this variable here, and it'll print off what n is. Let's save that. And let's cross our fingers to see if it actually works. And I'm going to run the pipenv. This opens a Python interpreter in the virtual environment we've created. From function, import maths. And what we're going to do is create our object, maths equals maths 10. And there we go, n is 10. We can see that there. Let's exit out of this. And what I'm going to do is I'm actually going to open up tmux. So tmux is basically something I use to manage Windows. So down here I've got sort of a command prompt, and up here I'm going to be able to write my code in Vim. So let's open up those files. Control P, function. So we have our function code on one side. Control P, test, and we'll put that vertically. And we're going to have our test code, or our test cases, on this side. So we want to create our methods, our addition and subtraction methods. So we're actually going to do what's known as test-driven development. We're going to write our tests first, and then write the code to pass those tests. So let's create our first test actually. So what we're going to do is we're going to import from function the class, import maths, and we're going to write our first test. Math equals maths, and we'll just create an arbitrary number, for example 10, and we're just going to make sure it exists. So we're going to use what we call an assert statement. An assert statement, basically everything after the assert statement, it evaluates to make sure it's true. And we're going to use is instance, which usually takes an object and a class. sorry, not a class, a type. So for example, an object could be a string of some sort, and we could use str to check if it's a string. But in this case, we can actually pass the object, which is maths, and we can actually check it against the class, and that'll work just fine. So we'll write that. And what we'll do is we'll come down here, and I'm going to type in pipenv run Pytest, and we'll see that it passes. So what Pytest does, it looks for any code that's prefixed with test underscore. It goes into that file, and if I just get rid of that, it will look for any functions that have the test prefix and run those functions. Now we're going to write our test cases. So we're going to create a method in the maths class called add, but we're going to write a test for it first. And what we expect is when we run the method, we should get 20 back. So for example, if we have 10 and we add 10 to it, you should get 20. And let's write a subtraction method. So subtract. Maths equals maths. And we use the same arbitrary value. And we'll assert that if we do maths dot subtract, let's say 5, that should equal 5, because 10 minus 5 is 5. I see a mistake there already. Great. Now if we run this, you'll see that there'll be some failures. For example, there's no attribute add or subtract, because we haven't written those methods yet. Let's write those methods. Def add, which will take self, and another variable, we'll call it x, which will be an integer. And what this function will do is it will return an integer. So self.n plus equals x, and we will return self.n. And we'll do the same thing for subtract. So I'll just yank the code, paste it here, and subtract. And you'll see I'll make a mistake, a deliberate one, and we'll see what happens to our code when we test it. So let's come down to here. I'm just going to swap it around, clear it, and I'm going to rerun our code. I'm going to use the tags -vv just to give us a more detailed look. And we see, I don't think I've saved this, that's why it's not working. Great, so I've just saved that. I'll run that again, apologize. Great. K is not defined. I don't know where I put K there, so let me just have a quick look back in here. There's some mistake I've made. There's K there, it shouldn't be there. Cool. Third time is the charm. Great. So we've passed our two tests, which is the add test, and if it exists, and we've found our subtract method, because we can see that when Python uses that subtract method, it gets 15, because we've done an addition instead of subtraction when it should be 5. So that's a great way of being able to write an automated test. I didn't have to, go into the Python interpreter, write out, import the maths class, create the maths class. I've done it automatically. So let's fix the error. And we can see that we've done our plus instead of minus. So let's change that. And we'll come back to here again. I'll just clear everything to make it a bit easier to see. And we can see we've got 3 tests that pass. Now, let's go back to our code. And we can see here, we've actually repeated ourselves quite a bit. We've got maths equals 10, maths equals 10, maths equals 10. It's only one line, but imagine if you have some object you have to create and involves many complicated steps. You don't want to be repeating yourself again and again. That's where we're going to use what we call fixtures. To use fixtures, we've got to import the Pytest library. And what we've got to do now is we're going to create a sort of a setup case. And we can use a decorator for that. So Pytest fixtures, it's basically a decorator which decorates a function. So we're actually going to use a function we've already, we've got this function here, but we're going to not use that. We're actually going to create our own. We'll call it maths, just to be nice and easy. And what maths will do, it will return maths 10. And now we've got this fixture, our future test cases can access that fixture if we pass through the function. So you can see here, I've just put maths without calling the function. I've created that reference. And we can actually delete this line here. because what will happen is maths will come into here. Maths will be the result of this. And we'll just do that for our next cases here. Oh, that was never going to work. Great. And what we can do is we'll delete these. And code's looking much more tidy now. We're not repeating ourselves as much. Let's come back to here. Clear. Run our tests. And we see that they pass. Good on us. Great. So Pytest is a really powerful tool that allows us to write automated tests. Being able to write automated tests means our code is more robust. It saves us time having to manually test our code, and it makes our code look nice, professional, and most of the modern packages these days use Pytest for testing their code, especially if it's in Python. So I really hope you found this useful. Please give me any feedback if necessary. If there's anything you're interested in, or any mistakes I've made, please let me know. I'd love some feedback. If you have any questions, I'd love to create more content on Python. I hope this really helps other people out there. So please drop a comment down below. Thank you very much and look forward to the next video. Stay Pythonic.